willingness to pay. And you can go back to our fundamental principles that we looked at in the first part of the course, and there when we had a demand function, we had private buyers' willingness to pay. And what we're attempting to accomplish through the state preferences is a representation of society's willingness to pay. And in our discussion last time, if we look at this basic relationship, recall that this would be an individual respondent's response with no to a particular willingness to pay, and that's based on the forces that drive the willingness to pay. And here we're assuming quite simply that it's only that respondent's income. However, if the respondent values that resource and values the resource more than the burden or the cost that they incur, and the cost that they incur, presuming that we specify the referendum correctly, is going to be the price or the willingness to pay that they offer. And here we're comparing the value, the satisfaction, to a particular respondent's if there is no change in the value of that natural resource versus if they value a change, and if so, they're going to have to pay the willingness to pay. This relationship about the relative size of these two values implies that any price that is less than A over B, given this simple relationship, any price that is less than that, the respondent should, under those circumstances, say yes. Why? Because the incremental benefit to them is larger than their incremental cost. And their incremental cost is what they're going to have to pay as P. All right? So, and moreover, if it turns out that under these circumstances, if in fact the willingness to pay in the survey says, are you willing to pay $60, for example? Well, if that price, $60, is less than A and P, you should say yes, right? Now, in contrast, if you get to a higher price and it's larger than A to B, then the respondent should say no, if the respondent is rational and not being strategic. So those are the details with regard to state preference, but once again, don't lose sight of the fact that all we're trying to do is to get a fix on societal benefits or total societal demand. Another thing to keep in mind as we go along is that the policies that are introduced by government sometimes presume that there is a certain target that the public sector wants to achieve. Now, that target may not be the optimal outcome with regard to setting incremental benefits equal to incremental cost. And to the extent that that target is different than the equation of incremental societal benefits with incremental societal cost, then it's not going to be optimal. Right? But for many examples, we don't know and can't measure accurately what is the social value or what is the social benefits. And in many cases, we can't measure accurately the social cost. So what does the public sector do under those circumstances? They set some target. And now the question is that target, can we offer a solution to achieve that target at minimum cost? Okay? So that's called a cost-effective policy. Right? So in your readings, all that is recognizing that you may not be able to determine the social optimum, but if through the legislative or democratic process, the public sector comes to a conclusion about what our target is with regard to minimal levels of sulfur dioxide in the atmosphere, and specifies those as targets. Now the question is, how can we achieve those targets as minimum cost? All right? But don't lose sight. Whenever you look at these problems, always keep in the back of your mind the lens that ultimately I want to get a fix on what the total social value of benefits are, and I want to get a fix on the actual social cost, including the private cost, plus the external costs that result from externalities. Okay? All right. So today we're going to look at air pollution, keeping in mind that overall framework, and we'll analyze stationary source air pollution, factories, fixed sources. These are in contrast to mobile sources or to vehicles, and there's a different set of policy interventions for controlling or trying to change the incentives so that emitters that have stationary sources of their emissions adjust their behavior to take into account their external cost. Initially, in this country and in most other countries, the policies offered by the government are command and control policies. And we've visited these kinds of policies already prior to the midterm, and now we're going to look at them in greater detail today with regard to just air pollution, but later it will be with regard to water quality, with respect to land quality, a host of natural resources. What are the sources of command and control inefficiencies? And they have been well documented because they've been around for a while, which has allowed economists and statisticians to come along and measure how effective those command and control policies have been. How effective relative to being the least cost strategies with regard to achieving a particular target, or how effective they are with regard to maximizing the net social benefits, social value less social cost. What are the benefits of cap and trade? We look at cap and trade, and here the public sector doesn't have to know each and every firm's cost that they face with regard to controlling pollution. They can set up a program and allow trading to take place, setting up another market for permits or the rights to pollute. A second source of pollution is mobile sources. And here we'll find a tension with regard to a number of public sector policies that promote more externalities instead of mitigating against externalities. And once again, we'll look at the different policies that are out there, and also what policies have been used both in the US and in the EU. And how successful have these policies either in achieving stated targets or stated goals, or how effective those policies have been in moving toward the social optimum. And cost-effective pollution control, once again, I've already explained what I mean by cost-effective, and we'll look at some specific examples. Okay, the Clean Air Act, which is a piece of legislation passed here in the United States and amended on a number of occasions, and that Clean Air Act is designed and is motivated by the problem with regard to air pollution entirely. And there's 5 parts of this particular program. The first goes to ambient air quality standards, which are set by the federal EPA. A second goes to new source performance standards. These are emission standards that attempt to set either new performance standards for new pollutants that are isolated, or different standards for new stationary sources. And And we'll see that with regard to this category, there are all sorts of unintended consequences. Think about new standards for efficient automobiles. And if the price of those automobiles is much higher because of greater efficiency, fuel efficiency, and less emissions of pollutants, and if those prices are much higher, relative prices, everything else constant, will drive more of the population for older automobiles. Right? And those older automobiles are less efficient and create more emissions and more air pollution. Continuing with the programs, there's a separate program for hazardous air pollutants, radiation, for example. The mobile sources, EPA regulates the mobile sources. California got out in front of the federal government and established its own policies with regard to regulating pollution from mobile sources, and as a result, it has played, historically, a leadership role in setting those kinds of regulations across the country. Acid rain, this is a problem. The precursor for acid rain is sulfur dioxide. And this was not a serious problem until the 1980s, when a number of high coal sulfur electrical power plants were emitting sulfur dioxide, and it led to rain, most of which fell on Canada. Canada didn't like this very much. And they entered into a serious program with the United States because of the externalities were largely imposed on Canada. And Canada wanted controls to be instituted, and the ultimate solution that was determined was to set up a cap-and-trade program with regard to sulfur dioxide, which, as economists would recommend to you, has been largely very successful. And the Canadians haven't complained, to my knowledge, since 1989. Okay, the taxonomy. There's a whole bunch of pollutants out there. These are some examples of pollutants who are recognized at higher concentration levels to impose health risk. Hazardous pollutants, these are also health risks that society or the public sector is certainly concerned about and is in the business of trying to control the transmission, admission, and ultimate ambient qualities and their effect on exposure to various segments of the population. Now, with regard to the policy, in particular the command and control, all of the command and control policies that are out there fundamentally have come to some conclusion about what the target is. And that is referred to in your reading for today as standards, emission standards. And just a note here to keep in mind, and we'll talk about this later, but it will occur to a number of you, that it's one thing to control emissions at the source, particularly a stationary source, but ultimately what matters is the dynamics of air quality, the ambient concentration of these different pollutants, because that is the source for the ultimate damage that takes place with regard to the health and well-being of the population. And right away, if that is where the damage takes place or where the harm takes place, there is a challenge to map from those concentrations back to the actual emission. Right? Okay. In the United States, there are two ambient air quality standards. One is a primary standard that is designed to protect human health. A second standard is secondary, and that is designed to protect aesthetics, physical objects, migratory birds, vegetation, the environment, if you will. And here is a table that gives you the target with regard to, in the first column, are a number of pollutants, carbon monoxide, and you've got to measure the frequency and come to some conclusion with regard to what your target is. And in the second column is the standardized values, and then in the third column, what I've listed here is whether it is just primary, or it's primary and secondary both, or it's just secondary. For example, if we go to sulfur dioxide, and you look at the target for sulfur dioxide, it is a 3-hour average, which gives the targeted value, and that is a secondary source that is concerned not with human health, but instead with aesthetics and the environment in general. All right, here is just a number of footnotes specifying the actual metrics that are used by EPA with regard to what's acceptable and what's not acceptable. For example, there is an instance here. To attain the standard, look at this one, the 3-year average of the 98th percentile, the 98th percentile in the full cumulative probability distribution, or frequency distribution, must be within that standard that's specified as 35 UG, and that was an effective standard specified as of December 17, 2006. I'm not going to hold you responsible for all of this. I just want you to get a flavor for the details that exist with regard to setting these kinds of standards or targets. Now, the enforcement of such standards exist with regard to the federal government, in particular the Environmental Protection Agency, and in setting the cap and trade, they have pursued the path of least resistance. Namely, let's impose these standards uniformly for certain pollutants. And that's true regardless of where those pollutants are emitted anywhere in the country. And those standards also govern the new source pollutants as well. And once they've set these standards, they turn to each state and ask the state to develop an implementation plan for achieving those targets. And those are referred to, as I've already noted, state implementation plans, or SIPs. The states, develop the plans, have to submit them to the Environmental Protection Agency for their approval. Because fundamentally all they're doing is saying, we're going to set the targets or standards, and then each state must develop an implementation plan for enforcing and achieving those targets, but we, the EPA, must approve whatever plan they put in place. Now, in terms of fundamental concepts, we know that we're never going to achieve efficiency, whether it be social efficiency or private efficiency, unless we're able to capture all of the gaps between the social willingness to pay and the social cost. Right? If we can capture all of that, then we will maximize net benefits. And that requires a measurement of both benefits and cost. Problem. The Clean Air Act, in terms of its original legislation, was largely now I'm going to go off on a sidebar about political economy and what happens with regard to stakeholders and interest groups and what ultimately the government does. The initial legislation was largely the result of environmental interest pursuing and convincing legislatures and the executive branch to pass legislation, and they didn't want cost to be considered. They want to achieve pristine environmental quality regardless of what the cost is. And this comes back to our discussion some lectures ago about the underlying legislation in this country is the polluter pays. And the polluter pays is a violation of the Coase theorem, right? Recall? So an economist, certainly an economist who fundamentally understands the Coase theorem, wouldn't find that sort of framework for designing policies very attractive. But the Clean Air Act says costs should not be considered. And we, the EPA, or we, the government, we, the public sector, representing the interests of society as a whole, and if we can't get a clear insight about what society wants, we'll communicate directly with God, and we'll set the targets that society should abide by and attempt to achieve. As a result, since costs are not considered, those ambient standards are likely to be inefficient. I have here are inefficient. That's a bit too strong, because they could be lucky, right? They could be lucky in the sense that they select the target or the standard that happens to be the one that equates marginal social value with marginal social cost. It's not very likely, right? Particularly if you don't attempt to represent and measure what the social costs are. Now, what are the sources of inefficiency if you sweep under the rug the cost? The first is the threshold concept, and the standard here is that a margin of safety must be achieved so that there are no adverse health effects on any member of the population. To meet that definition, control levels are going to have to be very stringent and very costly to achieve. An example, take the illustration of those portions of the population who have serious problems with regard to asthma. Now, if in fact the health standard is no one who, within our population, who is subject to such a tax will ever be faced with the exposure that would result in that health consequence. If that's the case, then many pollutants must be zero or near zero. And what is the cost of achieving that? All right, so those are the kind of inefficiencies that result. There are others as well, namely all of those standards that are set by the federal government are uniform across all states. And I've referred this here as spatial uniformity. And stop and think for a moment about what is the harm or the damage of air pollution in North Dakota versus San Francisco versus Los Angeles versus New York. The damage is much different given sparse populations, particularly in rural areas. And if you were taking into account a full analysis of the social benefits, you would recognize that the marginal damages are different across various states or different across urban areas versus rural areas. Temporal uniformity. The dynamics of air quality and concentration levels, ambient air quality, that changes with seasons. Slowly over time, the EPA has begun to recognize this, and when they state, for example, that there's a non-attainment area with regard to air pollution standards, it varies by weather conditions, for example. But the principal point that I want you to take away from this discussion is that efficient standards must recognize that the damage or harm, in particular the incremental damage or harm, changes across different seasons of the year. The fourth source of inefficiency is that most standards are defined at the emission level. And we're talking now not about mobile sources of pollution, but instead stationary sources. And if they're stated at the source of emission, is there a one-to-one correspondence between that and the ambient concentrations of those pollutants? And by the way, that fourth point has led to an entire industry of air quality experts who model the process of admissions to all the forces that influence the ambient concentrations where the real exposure takes place and where the real harm potential harm to health takes place as well. Okay, cost effectiveness. Based on what I've just shown you, it should be clear that it's very unlikely that command and control will be cost effective. And what I've done here is set a table of a number of studies that have been done after there was enough concrete data to evaluate the effectiveness of command and control. And these are mostly old studies that were done in the 1980s in which what people did is came along and said, researchers, I shouldn't say people, researchers aren't people, right? But anyway, these researchers came along and said, okay, I'll accept your targets. That's to say what the EPA stated as their targets. Now, to achieve that target, did the command and control, was it efficient? And now the measure of efficiency is, did I achieve the target with minimal cost? Right? Because we can't do net benefits, right? Because the target already is swept under the rug, the social value relationship, or the society's willingness to pay, and it's specified that you have to achieve that target. You shouldn't take into account cost. But what these studies have done is come along and said, okay, let's look at whether the command and control policies have achieved the targets at the minimum cost. Let me explain this table. This first column is a number of studies, which were, as I said, most of which were conducted in the 1980s. There are more recent one, 1995. These are the pollutants that they covered in their analysis. This is the geographic area where the study was conducted. This is the benchmark or the target or the standard set by command and control. And these were, if we look at this first study,